Hello everyone, welcome to Civil Mania. So today I'll be doing another numerical, that is the design and analysis of a rectangular water tank. So let me do the design. So first of all, let me open STAAD Pro, new project, space, next. Okay. So let me go to the geometry, run structure wizard. So in the run structure wizard, let me go to the bay frame, and in the bay frame let me go to as height as 3. So let me keep the height as 9. Okay, so let me keep the height as 9 meter, and along the height number of bay as 3, so 3 meter each, and along the width as 8 meter, so 2, and along the length also keep as 8 meter of 2. Apply. Okay, so this is now created. Close it, and yes, so this is what created. Now I have to create the staircases. So let me go to the view from positive z-axis. Now this is the beam. Here I'll right click it and insert a node. Insert the node, click on add midpoint. Okay, at midpoint it is created. Now I will create staircase in such a manner, such as, let me do one thing, let me show you how to create staircase. Control C, then control V. Now you have to place this coordinate at a distance of 1 meter along the positive z. Actually it is not, uh, let us keep at 2 meter distance. Yeah, in positive z. Now after that, again copy this one, copy it, and again V along the positive x at a distance of 1 meter. Yeah, now along, again copy this one and click Control V along the positive x at a distance of 1. After that, now let me copy this one, Control C, Control V at a distance of positive z at a distance of 1 meter. Yeah, again copy this one and Control C, Control V at a distance of positive 1 meter. Okay, after that let me copy this one, Control C, Control V. See, you have to do in such a manner as I am doing it. Simply you have to copy the node by selecting this node cursor and paste it by seeing this coordinate system, whether in positive x or positive y, or positive z or negative x, negative y, or negative z at a distance of z in 2 meter. Yeah, Yeah. So now let me make beam by using beam cursor. Sorry, not beam cursor. I have to click on add beam. Add beam. Okay. After that, sorry, let me again delete it because I have to use not the beam cursor. I have to use the, sorry, I have to not use add beam. I have to use add plate. Okay. Let me do one thing. Let me again copy this to, again select the beam cursor, copy this one and control V, and again in the positive X at a distance of 1. Okay, created. Now let me create this one, copy the distance of 1. Okay, yes. Now this is the point from here. Let me again copy it, control V, along Z at a distance of 1 meter. Yeah. Now let me do one thing. Now let me join it by the help of the plate cursor. This is the add 4 noded plate. Click on this one. Now what you have to do is, okay, now this is what I have created. Now again join it from, okay. So I have made one mistake, that is I have made these 3 points on this side. So let me do one thing. Let me select by the help of node cursor this one, this and this, and again copy, cut it. Okay, yes, simply copy it, these 3 node points, delete it afterwards. First of all let me copy it and again paste it at a distance of, I have to place on the other side, so at a distance of x 2 meter. Yeah. So now delete those node points. Yeah, delete it, again delete it. The beam was also deleted. Again let me draw the beam. Yeah. So done. So now again by the help of plate cursor let me join this one. Yeah. Yeah. So I'll show you in 3D diagram how the staircase is created. I hope it's clear to all of you. This is how the staircase is created. This is a one type of landing. This one is the landing and this one is the landing. Both are the landing. So I have created in this manner. Now let me do one thing. Now let me click on plate cursor and select the plate cursor. by selecting control. Now after that, do translational repeat along the y direction, step length 3, number of steps 2, and click on OK. See, now the staircase is created up to the top. I hope it's clear to all of you. Now the staircase is created up to the top level. After the staircase is created, now let me go to the general, then go to the property and define property. In the property, go to the rectangular section. Let me provide in this water tank, let me provide the beams of size 0.30 by 0.30 and columns of size 0.40 by 0.40. Add it. Okay, now again view from positive Z. Now let me do one thing. Now let me do one thing, that is, let me do cut section. Select to view. See, I will assign this reference 1 and reference 2 properties afterwards together. First of all, let me create the water tank above this frame. Okay, this is what I have selected. Now go to the positive, this one, and here now I'll copy the same thing, that is now let me copy the nodes. Let me show first of all the nodes, display the nodes. These are the nodes. I can show the node, sorry, node points, apply. Yeah, these are the various node points. Now click on node cursor and copy all the nodes, because I have to create the height. Yeah, I have copied all the nodes. Now control C and now control V. In the y direction, I have to create 5 at a height of 5. Okay, done. See, now this one is done. So now simply you have to copy, simply you have to select these all nodes and click on sorry, you have to select, let me see from the positive. Okay, this one is not to be created in such a fashion. So let me do one thing. After that, go to the geometry. Now connect the beams along the y-axis. 8 members are created. So now they are connected. Okay, so now they are connected, but remember that in the water tank we don't have to create the lid of the water tank, so I have not placed in the top portion the plates. So now I have to join them by the help of the plates. So add 4 needed plates. See, I have created on all the sides the plates. Now even I have to create at the bottom portion, that is where water used to stay. So now I will show you by the help of the 3D figure. Just wait. Full structure. Yeah, see, I hope it's clear to all of you how it is created. See, in the bottom portion the beams are not present, so I have to even click on all the beams. Also I have to show their sections. So let me do one thing, let me go to the property, and let me go to the property, and now let me again assign all the beams. These are the beams. So select beams parallel to X and select beam parallel to Z. So assign to the selected beams. Now rectangle, select the beams parallel to Y, assign to the selected beams. Now let me again check the figure in 3D view. Okay, but remember one thing, that in the water tank this beam, these columns which are present, these columns we have to delete it, because the columns are not present on the on all the sides, so you have to delete it. So what we have to do is, so you have to delete this beam, delete the beam, physical beam deleted. Now let me go to the cut section, again cut it only this portion. Okay, now after that go to the 3D view. Now delete it, or else some other thing will get deleted. Now the beam is deleted. Now again by selecting the beam cursor we have to delete it. Now delete, now beam, delete the beam, now delete the beam. So everything is now deleted. Again view the full structure. Now check for the 3D view. Yeah, everything is now deleted. Even the corners where the column is present, that also I have to delete it. So let me again view from here. delete it, delete it, delete, delete it, delete it, delete it. Again check for the 3D figure. Yeah, everything is deleted on all the four sides. This is how the water tank has to be constructed. But remember that in this the staircases are created, but now no balcony is provided. So I have to now create for the balcony. So now again go to the front view, and I have remember that here I have not provided the thickness of the slab because I have to do provide some slabs for the balconies. So first of all I will provide the slabs for the balconies, then after that I will provide the thickness of the slab in altogether manner. Now let me do one thing. Let me go to the this view, then geometry, then here cut section. Let me go to this section. After that view from positive x. Now after that I will now create the balconies. So now let me click on copy, -2 meter, 2 meter on minus z, 2 meter on minus x, 2 meter. Now after that 2 meter will be created on this 2 meter on the x axis and in the minus z also -2. 2 meter x, 2 meter in so now let me create the these are the balconies which I am creating it. See, here I have to again create another one. Here I have to create one. Here I have to create one. So what I have to do is again copy, click on node cursor, copy it and paste it at a distance of minus z. Now click on create cursor again, create it. So I'll show you in the 3D view how uh, it's like. See, this is how the balcony, I have created the balcony on all the sides of the water tank. And now I'll copy this one. Okay, so let me see once more. If there is any problem, see, this is how the water tank is required to be constructed. Now let me again go to the general section, and here again go to the 3D view in geometry part. But remember that I have not created in the staircases. Let me check in the 3D view. See, in this is the staircase, and in this staircase I have not created the beam. So I have to create the beam in the staircases. So let me do one thing. Let me create staircases, beams in the staircase. So select the add beam button. Okay, select the add beam button and click on beam. From here to here I have to create beam, and from here to here I have to keep on beam. So again from here to here beam, from here to here beam, from here to here beam, and from here to here the beam must be present. And again go to the general portion and check for the select beams parallel to z axis. Again, now check for the, see, now it's okay. See here, these are the beams, these are the beams. So this is what the structure is, structure shown. It should be like, see here, because this is the one kind of slab, and this slab must rest over this beam, and this slab must rest over this beam. So this is how the structure should be like. Let me take one screenshot of this figure for my thumbnail. Okay, so I'll save it now. So the tank is completed. Now let me provide for the thickness of the as 125, no one, provide as 120 as the thickness of the slab. Edit. Now select on assign to view, use cursor to view, assign to view, assign it. Yeah, I have provided the thickness of the plates. Now I will provide support. Now let me go to the support and click on this view and provide supports. Sorry, first of all let me create support, fix support, edit. Okay, let me click on this one, then click on this in the same manner. Now let me view in the 3D. Okay, as you can see here also the nodes are being created at the center, so you have to delete these two nodes. This is not required. So again, let me again go to the property and plate, select the beams parallel to Y. Yeah, let me go to the support, general, support, go to this front view or go to the side view and click on this three and click on this one and click on this tree, and after that you can check, yeah, all are being selected. Now assign to the selected nodes, assign it. Yeah, now I have assigned the supports. After assigning the supports, now let me do one thing. Now let me provide the load. Now let me go to the load case, no, sorry, let me go to the definition. In the definition, I'll be providing here, one is the wind load and seismic load. And so first of all, let me go to the seismic load, seismic definition. Go here, go to the seismic definition, go to the IS 1890 2002 2005, click on generate city. I'll be designing for Delhi. Okay, 0.05 will be the moment damping ratio. Hard soil, let me design for the medium soil. Generate, add. Okay, add it. After that, the uniformly distributed load. Here what are the beam sizes? Here the beam sizes are zero point 3 by 0.3. So 0.3 into 0.3 into calculator. Here the beam sizes are 0.3 into 0.3 into 25 for RCC, 2.25. So 2.25 will be the weight. So minus of 2.25. Sorry, here the weight will be 2.25. Not required minus of 2 to edit. Uniformly distributed load. Now go to the select beams parallel to X and select beams parallel to, click beams parallel to Z axis. So all the beams are selected. Now assign to the selected view, assign. So weight is also assigned. So weight is also assigned. After see, now for seismic it's done. Now let me go to the wind details, add. Okay, wind. Now let me go to the wind again, add it. Now calculate as per ASCE 2010 category 3 for Delhi. As per IS 875 part 3 it is 47 kmph. Exposure is C. Building structure, okay. See, we can see here truss tower, lattice frame, open solid sign, chimney, tank and similar. See, water tank. See, we can see. For now click on apply, and after that chimney, tank and similar structure. Height is, what is its height? Now I have to check for its height. Okay, so its height is 3 3 3 15. After 15 it's again 5, means its height is 20 meter. So I will even show you afterwards what is the height here. So list horizontal dimension. Here the dimension in the horizontal dimension is 8 meter and 8 meter, and here also in the vertical direction it is 8 meter. Okay, apply it. So now the pressure, okay, apply it. Okay, click on OK. See, up to the 20 meter it's created. What will be the intensity? Up to 20 meter it's created. Now click on add factor as exposure factor as 1, add it. Okay, done. So add, assign to view. Okay, it's created. So now I will calculate the height again. So let me check the height. So you have to click on this node to node distance from here to here. What is the height? Okay, sorry, it's 14 meter. Let me check once more from here to here. Height is 14 meter. Okay, so let me do one thing. Let me again edit here. Now go to here, edit, and go to the intensity, edit here, and calculate as per AC. Everything is okay. Height, here height is 14. Apply it. Okay. Yes. Okay. So up to 14 meter is created. So I have to delete this one. Yeah. Change it. So let me do one thing. Let me close it. Let me delete this one. Let me go to the intensity, edit it, and calculate. So everything is okay. Now go to the design of this one, 14.8. Okay, now design pressure. Okay, let me do one thing here, edit it. Yeah, everything is okay. Close it. After that again edit it, calculate, done. Yes, change it, close it. After that again go to the wheel here. Let me do one thing here, edit it, close it. Let me delete it and click on here, edit factor. Go to home definition, add it. Okay, now I can add. Then first, sorry, calculate category 3, 47, exposure C, building structure, water tank, and apply. Here height is 14.8, round. Okay, here you have to check whether the section is round or square. It is square. It is of square shape. Okay, click on apply and click on here. Okay, applied. Now up to 14 meter. Yeah, add it, factor 1, add it, done. Now exposure, assign to view, yeah, done. Everything is now done. Now after that, go to load case detail, add. First of all, you have to add for the seismic load x axis, seismic load z axis. Then after that, wind load, go to the wind load x axis, wind load z axis. Now dead load, simply click on dead load. Then after the dead load, you have to now create on fluids, fluid load, close it. Okay, here I have not even created another load. I have to create live load. Live load created, done. Now go to the seismic load. You have to click on add. In the seismic load, I have to click on add. Then go to the seismic load. Then add it. Now go to the seismic load, again add seismic load z-axis factor 1, add it. Now wind load, go to this wind load, click on wind load, then x range is, what is the range here? Here the range is wind load will be created, x-axis, okay, x-axis factor will be 1. Each minimum range is from 3 to, what will be the minimum range? Each minimum range will be 3 to 14. Now minus 1, 3 to 14. Okay. Now Z, in the Z axis the wind load will be along Z 1, 3 to 14, minus 1, 3 to 14, add it. Okay, done. Now dead load. Now you have to apply dead load, that is factor of the safety as 1. Simply I will apply for the self load. Okay, I will simply here apply for the self load, because I am not applying here load of the floor finish or no any kind of floors, because here fluid pressure will be already present, so that one will accommodate for everything. And here neither walls are present, nor partition walls, nor load bearing walls, so here only self weight will be present, that is assigned to view. Do it as assigned to view, done. Now first calculate for live load as, that is in the live load it will be floor load of -2, and this one will be applied at this level. So what will be the height? 3, 3, 3, so 9. So minimum is 9 and maximum is also 9. We'll apply it at here along the y direction. Add it. Yeah, added. Now what will be the floor? No, what will be the fluid load? This one is actually the fluid load, FL. Instead of FL, you write it as fluid load. Now in the fluid load, again add it. In the fluid load, we have to apply the hydrostatic load. Where is the hydrostatic load? Go to the floor load, snow load, wind load, plate load. Yeah, go to the plate load. You have to go to the plate load, and there you can see hydrostatic load. So simply click on this hydrostatic load. Now select the plates. Now you have to select the plates. Done. Apply in the y direction, global y. What will be the weight? The weight will be of around minus 10 kilonewton per meter square to minus 30 kilonewton per meter square. Add it. Done. So do one thing, as it's not getting added, so you can do one thing. For the fluid load, you can simply go on pressure on the full plate, and you can add one load as minus 30 on the y-axis. Add it. Yeah, I have applied the fluid load, either hydrostatic load or the pressure on the full plate. I have added it. Now I have to use cursor to assign. Use cursor to assign, or I have to go on this view. Then I will select the plate. Then assign to the selected plate. Assign. Now, yeah, I have assigned the fluid load. Now everything is being assigned, as you can see here. Now simply you have to go on analysis, and let me check once more. Let me go to the property. The plate thickness I have assigned. Yeah, everything is now assigned. Let me simply go to the analysis and pin, add it, close it. Now go to analyze and analysis. Yeah, so now there is two errors, so you have to now rectify the errors. So let me go to the output file. Okay, so what is the error? Warning, joint number 48, joint number 52 not connected. These two joints are not connected, joint 48 and 55. Okay, so now let me do one thing. Now let me go to the diagrams and show node numbers 48 and 55. Okay, you can see here this one is 48. Okay, this is joint number 48. Let me do one thing. Let me delete this joint. Simply delete this joint. Yeah, 48 and 55. Let me delete this joint also. Okay, now I hope everything is clear. Now I have deleted these two joints. Now let me again view the 3D figure. If anything is wrong, yeah, everything is okay. Now let me again do the analyze part. Before analysis, click on analyze and print add. Now do the analysis and analysis. Again error is there. Okay, now let me check what is the error. Error in support. input or there is no support input, error in support input or there is no support input, analysis will not. Okay, or there is no support. Okay, so there is no support. Okay, I have not provided support somewhere. So let me do one thing, let me go to this part. So remember that while doing the analysis, sometimes the this kind of problems might occur, so you should know how to rectify these problems. Yes. Okay, so let me check for if somewhere support is not created. Yeah, now again click on analyze and print edit. Now click on analyze. So now let me check once more, again error. So now let me check what is there, error in support input or there is no support input, same error. Okay, let me rectify it.